Okay, now this one's got a big long title, so I had to put it a bit lower on the page. But we're going to be looking at adding and subtracting algebraic fractions. I can tell you're excited already. All right, so step one, it's pretty easy. You write your fraction down. You got to actually have that as the first part. Got to have the fraction so that you can deal with it. Okay, next part. I'm going to lose our title here. I'll move this up. So step one, we've written our fraction. Step two, we actually have to find the lowest common denominator by looking for the lowest common multiple. Okay, so lots of big fancy words there, I guess. It's pretty simple though. You want to find a number that you can divide both of your denominators into. That's the lowest number that we can find, just simply because it makes our jobs a whole lot easier. So looking at our work that we have here, we've got a 3 down the bottom here, and we have a 2 on the bottom down here. What you'll often find is that the lowest common multiple between your denominators is the number that you get if you multiply the two denominators together. So if we've got a 3 down here and we've got a 2 down here, if we multiply those two numbers, 6, well, 6 actually turns out to be the lowest common multiple of 2 and 3. So what do we need to do to this 2 to get it to 6? Well, we'll need to multiply it by 2. But it's important to remember that whatever we do to the top of our fraction, we have to do to the bottom of our fraction, and vice versa. So because we want the 3 to become a 6, and we're going to multiply it by 2, we have to multiply the numerator by 2. And this denominator of 3, we want that to be a 6. So what are we doing to the denominator? We're going to multiply that by 3, and we have to multiply the numerator by 3 as well. And you'll see that that's exactly what I'm doing. So we simply do those multiplications. 2x times 2 will give us 4x over 6, and x times 3 is 3x over 6. And that is what I have. I have my equivalent terms, my equivalent fractions. Okay, so step 3, let's move on to that next step. Step 3, what we need to do is express my new equivalent fractions as a single fraction. Okay, so let's do that. I'll show you how we do that. Because we have the same denominator, we can basically combine that. We can collapse it down and just have the numerators still being subtracted, but because we have a common denominator, we can collapse it. We then simplify our expression in step 4, and 3x, if we are taking that away from 4x, that will leave us only 1x left. And our answer then is x over 6. That's the simplified answer to our original expression. Okay, let's do a more sort of tricky one. We'll do some more of the tricky ones so that you can see how they work. Okay, here's my initial expression. 2 over 3x minus 4 over x. Now, what's trickier about this one is that the unknown, the x, is actually in the denominator. We don't really care too much. It doesn't really matter that it's down there. We still go through the same process. We need to find the lowest common multiple, the lowest common denominator. Once again, I'll tell you that the easiest way to do it is multiply the two denominators together, and 12 will be what we're looking for, but it's actually going to be 12x. So what do I need to do to 3x to make it 12x? Well, I'd have to multiply it by 4. And what we do to the denominator, we have to do to the numerator. And same on the other side of the subtraction sign. I had to multiply it by 3, and there's a 3 above that as well. Very good. So I can multiply these out. 2 by 4 is 8. 3x by 4 is 12x minus 1 times 3 up here will be 3 over 12x. And you can see that that's what I've done. I then will simplify it by collapsing it down into one single fraction and doing the subtraction on the top. Oh, lost my words there for a bit. And we'll get 5 over 12x. That's it. Simply done. When you start to get into a little bit of bother, it's not that it's harder, it's just more work, is those times where we have expressions, like the expression down the bottom in a denominator. So down the bottom of this particular one, this example, we have x plus 3 as a denominator on one side, and we're adding something over x plus 2. Now we need to find the lowest common denominator. Now, just like we have done in the past, if you multiply the two denominators together, we'll have our lowest common multiple. So the lowest common multiple of x plus 3 and of x plus 2 will be x plus 3 times x plus 2. So this denominator then becomes what I need to multiply this denominator by, and this denominator is what I need to multiply that one by. It sounds a bit messier than it really is. Let's have a look. Okay, so we have our initial, this is what the terms that we started with over here, the expressions, and we're multiplying it by the same thing on the top and the bottom, because that's very important, otherwise we won't have equivalency. And we end up with the same over this side, so that when I reveal you the next line, you'll see that we actually have common denominators now. Common denominator is open bracket x plus 3 close bracket, open bracket x plus 2 close bracket, and that is on this other fraction as well. Okay, once again we follow the same simple rules. We can collapse that down into a single fraction, which is what we do here in this next step. There it is, all is one fraction. We then have to simplify. Now, simplifying in this case is going to involve actually multiplying out these binomials, and they'll end up using the FOIL method. You'll end up using the FOIL method to do that. When we do, we are going to end up with two quadratics right there on top of our common denominator. Once we have it in this position, we actually can simplify these two terms on the inside because they are like terms on both of these, and we are going to end up with a simplified, it's not completely simplified yet because we can get rid of these brackets because we know that addition is commutative. As long as we don't mess around with this minus 3 at the end here, we can get rid of these brackets and we can just work it all out. We end up with an x squared plus 2x squared. That'll be 3x squared. We have plus 3x and a plus 5x. That'll be plus 8x. And then just the constants, we've got a plus 2 and a minus 3. Well, 2 minus 3 is negative 1. So when we get to the final answer for this particular question, we have 3x squared plus 8x minus 1 over our common denominator, which was x plus 3 times x plus 2. Now you'll note that I never actually multiplied out that denominator. We don't normally tend to do that. We keep our denominator as the fraction, as the factors. Wrong word. Okay, so adding and subtracting of fractions is much trickier than multiplying and dividing them.